Hey guys, sorry, I didn't realize it was recording. So, moving on to chapter 6 for week 2. Chapter 6 is going to be one that probably a lot of people struggle with. Once you get the hang of it, though, you'll be great and you'll never have to worry about learning how to do a dosage calculation again because they're all pretty much the same. So, the book first starts discussing unit dose form, and what unit dose means is that the pharmacy takes and packages the medication in a either a unit dose tablet, so each tablet's packaged in a little plastic case, which you have to rip open, kind of like what you see in over-the-counter medications, except for it's labeled with things that are important, like an expiration date that we've determined, or a generic drug name, as opposed to just the brand. They could also come in a vial or a pre-filled syringe made by the manufacturer, so you can see a lot of different unit dose medications. Very rarely do we dispense something in multiple doses, strictly because you're only going to use one dose, most likely, and we don't want you to have access to more or waste, so that's how we cut down on waste. The chapter then moves on to talk about a basic arithmetic test. I would take it, see how you do, get better if you can't, do really well in the first round, and the end of the chapter has the answers, so keep that in mind. If you have any questions on basic arithmetic, contact me. I'll try to walk you through it either via email or a quick phone call. But it should be pretty much reminiscent of high school math. So, method 1 for them. I hate method 1. I'm not going to go over it. I don't like it. Should you do some examples and decide you like it, by all means stick with it. Do what works for you. However, I am more of a ratio and proportions kind of girl. So let's talk ratios. Ratio is when one number is over another number, and you'll see a lot of drugs this way, okay? So a ratio, I'm going to try to hold this up. So let's say ketorolac is available in a 60 milligram per 2 ml vial, right? So every 2 mLs will contain 60 milligrams. That's kind of backwards, isn't it? Maybe this isn't going to work out as well as they wanted it to. So what happens when we do that ratio is we know that if there's 60 milligrams in 2 mLs, there's 30 milligrams in 1 ml. That's pretty simple math. You can do that in your head. Let's say that you needed something a little more specific, though, a little different than just simple math. Let's say you knew you needed 15 milligrams of ketorolac. And again, this is going to be backwards, but try to follow along. I'm sorry, guys. If you needed 60 milligrams, or if you had 60 milligrams and you knew you needed 15, so you've got 60 milligrams in 2 mLs. Now you need 15 is what you want. How many mLs would that be in? For a lot of you, this might even be simple math as well. So ratios are what I like to work with because you can easily cross multiply and divide, right? So now we've got 60 times x, 60 milligrams times x mLs, and we're going to set that equal to our other multiplication. 2 mLs times 15 milligrams. 2 mLs times 15 milligrams. So we know this equals 30 mLs times milligrams, and this equals still 60 milligrams times x, because we're solving for x. So now we're going to divide, so let's rewrite our equation. 60 milligrams times x mLs is equal to 30 milliliters times milligrams. We always want to keep our units constant because we want to make sure that we have appropriately done our math to solve for the correct units. So to get rid, we want to get x by itself. Here sits x tied to 60, right? Or backwards 60 here. To get x by itself, we're going to divide 60 out of that equation, okay? I was going to go out and buy a whiteboard, but I'm being cheap. I don't want to spend the money, so I'm doing this on computer paper. So we're going to divide 60 milligrams right out of that equation. Cancels the 60 milligrams on this side, as well as we're going to need to divide it on this side, right? Okay, yeah, that makes sense. So here we have 30 mLs times milligrams divided by 60 milligrams. Our milligrams cancel out, which is good because we are solving for x mLs. 30 divided by 60, use your calculator, you'll get 0.5 mLs. X mLs, because we're left with x on this side, is equal to 0.5, right? Again, sorry that's backwards, but hopefully it helps you out. And I'm sorry, my writing's really messy. I've been a pharmacist for a long time, and I've been working in the medical field for a long time. This will happen to you too, unless you're one of those people with perfect handwriting, which is really nice if you're a nurse, because we love nurses with perfect handwriting. So we had 60 and 2. We needed 15. We found out that 15, we could use 0.5 mLs. Now in this case, even though it's a unit dose vial, we're going to use that 0.5 mLs, throw out the rest of the vial. It's not always going to be able to be used. So that's a vial if you were doing an injection. Let's say you had a little baby and you needed to get that little baby some liquid medication. This is where people start to get tripped up a lot. So our baby, right? Our baby is gonna need 100 milligrams. He's tiny. He needs 100 milligrams of amoxicillin, right? Amoxicillin comes 250 milligrams per teaspoonful. Now, if you remember what your teaspoonful was, because we're dealing in the metric system, we like to stay away from this household stuff until we tell the patients what they're going to take at home, because they don't know what 5 mLs means. So a teaspoonful is 5 mLs. 250 milligrams per every teaspoonful. We know we need 100 milligrams. So it's on the same line as the milligram. 250 milligrams in a teaspoonful is equal to is equal to 100 milligrams in X mLs. 1 teaspoonful equals 5 mLs. Don't forget that. So we're going to solve for X. Same exact setup. We're going to cross multiply. So 250 milligrams times X mLs is equal to 100 milligrams times 5 mLs. Okay, so moving forward, this is really kind of more difficult than I thought it would be. Moving forward, and I can meet with you guys at some point, probably not next week because I'm working 10:30 to 9. However, I can meet with you guys at some point to do math if you'd like to, together in person, so that if you're struggling with it, it makes it a little clearer, it makes it a little more sense when you see it face to face. So we're going to continue to solve for X. So we're going to get rid of that 250 milligrams, right? We want X all by itself. So we divide by 250 milligrams on both sides. Probably should have done this multiplication first. No problem. We can kind of do that in our heads and then divide. So 250 milligrams cancels out on this side, leaving X mLs by itself. Milligrams cancel out on that side, leaving mLs by itself, which is good. That's what we want. We want to know how many milliliters we need to give this little baby. 100 times 5, anyone? 500 divided by 250. Use a calculator just in case you're ever worried about getting anything wrong. No one is going to fault you for using a calculator. I don't do math in my head. I don't pretend to do math in my head unless it's really, really simple. In this case, it kind of is simple, but always use a calculator. Feel comfortable doing that. 100 times 5 is 500 divided by 250 is equal to 2 mLs. So every 5 mLs has 250 milligrams, but to get our 100, we need 2 mLs. Wish there was some way to make this a little easier so that it wasn't backwards for you guys. But set up your ratio, make sure your units match, and start cross-multiplying and dividing. If you find that method 1 works better for you, use method 1, okay? Go through the examples, follow along with them. They use proportions. Proportions are similar to ratios in that there's no line, there's just a dot dot. That dot dot is the same thing as a line. You're still going to have to divide out. You're still going to have to get X by itself. Okay, so in this first example, they are asking you to, you have Demerol 60 milligrams, but it comes 100 milligrams and 2 mLs. So you know you have 100 milligrams. It would be over 2 mLs or dot dot 2 mLs. So that's a proportion. And you know that equals 60 milligrams equals X ml, or to X mLs. Okay, so really what we're doing is we're solving for X. We're going to multiply that 100 times 2, and we are going to divide by 60. Same idea, we're going to get the same answer as if we set up 100 over 2 equals 60 over X. So follow along with all the examples, do them over and over again until you feel like you have it correct. So, calculations. Pediatric dosages. You cannot merely take the portion of an adult dose and give it to a child. They're not tiny adults. Their systems are not as developed as ours. Their kidneys might function slower. Their liver might function slower, especially the tinier the human. So NICU, little preemie babies, very important to remember this. So you will see doses given in milligrams per kilogram. You might have your weight in pounds and you'll need to convert to kilograms. The book gives an example of how to do that. convert pounds to kilograms, you always divide the number of pounds by 2.2. If you have kilograms and you need to get to pounds, you multiply by 2.2. Keep in mind, your American weight is maybe 150, 160 pounds, right? Your weight in kilograms is always smaller. So when you're trying to remember how to get from one to the other, division will take you smaller, multiplication will make it bigger. So if you need to go from pounds to kilograms, you know you need to get smaller, so you're going to divide by that magic 2.2. So they talk a little bit about Clark's rule, and I want you to go over that on your own. It's not commonly used. Most drugs come with pretty specific dosing recommendations for children. 100 milligrams per kilogram, 10 milligrams per kilogram. So if I had a child that was 10 kilograms, and I know my ibuprofen suspension needs to be 10 milligrams per kilogram, that 10 kilogram child, multiply that by that 10 milligram per kilogram dose, is going to give me 100 milligrams. Okay? Geriatric dosages. Big book. Special consideration must also be given to the preparation and administration of safe dosage for older adults. Usually, what we're most concerned with here, and the pharmacist is usually responsible for checking this and making sure we get it right, is our kidney function. If someone has reduced renal function, we will adjust that dose. We will call your doctor. We will call you. We will work until we make sure that dose is adjusted. So usually, instead of a dose being given as frequently or as high of a dose, you might see a dose given once a day instead of twice a day, or at a lower dose for an older adult. I hope that helps. I know math can be scary and confusing for a lot of you guys. I'm sorry it was backwards, something I didn't even think about with the camera. However, I am available to meet early in the morning if you need to, before 10 o'clock, or we can always try calling over the phone or emailing, and maybe I can help you out that way. I hope you guys have a great rest of your week, and email me with any questions.